what if your car could warn another one, like 3 blocks away, that there's some black ice on the road? Or what if a really bad T-bone collision just didn't happen because both cars knew what the other was about to do? I know, it sounds a little bit like science fiction, right? But this is the very real future of road safety that we're going to dig into today. And to really get why it's so important, we have to start with the problem it's trying to solve.
And to understand why this matters so much, we have to start with this number. It's pretty staggering. According to the World Health Organization, road accidents cause about 1.2 million deaths every single year, all around the world. That's basically a global health crisis happening on our roads every single day.
So that's the big question, right? What do we do about it? I mean, beyond seatbelts and airbags, how can we fundamentally change the game when it comes to road safety? Well, the answer, like it is for so many things these days, might just be in the technology.
And that brings us right to the heart of what we're talking about today. This idea of creating a huge interconnected network where our cars are just constantly talking to each other to stop accidents before they can even start. The tech behind this whole thing is called a VANET. That stands for Vehicular Ad Hoc Network. And the concept is actually pretty simple when you break it down. A VANET basically turns every car that's part of it into a wireless router on wheels. They all connect with each other, and boom, you've created this constantly moving mobile internet right on our highways.
Okay, let's dive into that a little more. So every car in the network gets a unique ID, and it acts as a little node. It can connect to any other car that's within, say, 100 to 300 meters. Now, as cars are moving all over the place, some drop out of the network, new ones join in, you get this really fluid, dynamic web of information. And the whole point of it? To constantly share critical safety data. You know, stuff like your speed, your exact location, or if you're suddenly slamming on the brakes.
So this communication, this talking, it happens in 2 main ways. There's vehicle-to-vehicle, or V2V, and then there's vehicle-to-infrastructure, or V2I. Let's take a look at how they work together.
This whole network really relies on 2 types of communication that are happening all at once. The first one is direct, vehicle-to-vehicle, V2V. That's where cars are just talking straight to each other. The second is vehicle-to-infrastructure, V2I, and that's where cars communicate with fixed things on the side of the road, like traffic lights. You really need both for the whole ecosystem to work.
So let's kind of put them side by side. V2V is awesome for short-range stuff. You know, a car can instantly warn the car right behind it that it's hitting the brakes hard. Plus, it doesn't need any expensive infrastructure built out, which is a huge advantage. The catch? Well, as cars are zipping around at different speeds, that connection can get a little unstable. V2I, on the other hand, solves that stability problem. It uses these fixed roadside units. You can think of them as Wi-Fi hotspots, just for cars. This gives you a much more stable, longer-range connection. But, of course, it comes with a price tag. You've got to install all that new hardware.
Look, having cars that can share warnings with each other is a massive leap forward. But what if the car couldn't just get the warning, but could actually act on it way faster than any human possibly could? This is where these 2 worlds, vehicular communication and autonomous driving, start to merge.
All right, first, just a quick definition so we're all on the same page here. An autonomous car is, simply put, a vehicle that can sense what's going on around it and get where it needs to go without a person having to touch the steering wheel, the brakes, or the accelerator. And this really illustrates the ultimate vision. Just picture it. A car way up ahead hits a patch of ice and starts to skid. Instantly, it broadcasts a danger signal to every car around it. Your car gets that signal, and before you even have a split second to react, its autonomous system kicks in, takes control for a moment, and just expertly maneuvers you onto the safest possible path. The collision is completely avoided. I mean, that's the dream, right?
But, you know, just like with any revolutionary tech, there's a big gap between that dream and where we are today. There are some pretty significant challenges we have to figure out before that vision is a reality on every single road.
It really boils down to 2 huge hurdles. First, there's the AI problem. We have to develop an artificial intelligence that's smart enough to make life-or-death decisions in a fraction of a second. Then, and this one might be even trickier, there's the novelty problem. Think about it. Even the most advanced AI is trained on data from things that have already happened. So how can we be sure it will react correctly and safely to some bizarre, chaotic situation it has never, ever seen before?
So because of those challenges, the most likely path forward, for right now at least, is semi-autonomy. So we're talking about creating systems that can take over in a crisis, but, and this is the key part, where the human drivers can easily and instantly take back manual control. It's kind of like a stepping stone. It gives us that extra layer of safety without forcing us to solve the entire AI problem all at once.
Which brings us to our final question. The technology for talking cars is pretty much here, and the potential to save millions of lives it's undeniable. But it all kind of hinges on this one thing. As a society and as individuals, are we really ready to trust an algorithm with our safety in those absolute most critical moments? Well, that's something we're all going to have to decide.